Hi, and welcome to 5 effective strategies for answering CXC Multiple Choice Mathematics Examination questions. The first technique we are going to look at is a technique called elimination. Elimination is best used when an answer cannot be derived from the question unless all options are fully explored. If you look at this question, for example, we can look at our elimination process. We eliminate the obviously incorrect answer. We know that the hypotenuse is the longest side of the right angle triangle, so that the length AC is greater than BC. So we know A will be true. Looking at our option B, if we are given a right angle triangle like this, and C is your point of reference, here is your opposite side and here is your adjacent side. The tan of the angle C would be opposite over adjacent, and the opposite side is AB and the adjacent side is BC. This would also be true. Let us look at part C. They are saying the angle BCA plus angle CAB is equal to 90 degrees. This is also true because the sum of the two angles that excludes the right angle in a right angle triangle is 90 degrees. So therefore this is also true. If therefore A, B and C are true, then this means that D is false.
So D is the correct answer.
Here's another example. But to do this question, let us start off using a form of transformation that we are familiar with. Let us start using a translation. Suppose if we had this as our pre-image. Remember, a translation is a horizontal, a vertical, or both a horizontal and vertical movement. So that if this is your pre-image and it moved in this direction or even in this direction, then one thing is for sure, that the orientation does not change. And because the orientation changed in the image shown in the question, we know that this cannot be a translation. Let us examine if it is an enlargement. An enlargement generally magnifies the pre-image. However, it can get smaller if the scale factor is between -1 and 1. However, because the orientation changed, this only happens when the scale factor is between 0 and -1. Clearly, the scale factor is on the positive side. This eliminates this being an enlargement. For a reflection, if this were your pre-image and it were to be reflected to go to the first quadrant, then it must be reflected in the line y equal to -x. And your image would look like this. Clearly, this is not the same orientation as in the picture, so we can also eliminate a reflection. By virtue of elimination, we can tell that this is therefore a glide reflection. A glide reflection is a combination of two transformations. For example, if you had this as your pre-image and this as your mirror line, it is a reflection first, followed by a translation. Now this looks like the image in your question. In most multiple choice items, there is usually an answer that is outrageously incorrect. If I were to look at the shape of the parabola, it is concave upwards. But looking at response C, I see the coefficient of x squared is less than 0. But we know when the coefficient of x squared is less than 0, the parabola is concave downwards. In other words, the graph will produce a maximum value. So therefore, we can eliminate C as a possible answer. To do the substitution aspect of this technique, we will need to have some strategic points. And the points we are going to use are coordinates on the graph that are of integer values. These are your coordinates with integer values. If I were to select, let's say, -1, 2, and substitute x is -1 in your response B, then I will have this. This would simplify to this, which is 14, but you would recognize the coordinates are -1, 2. 14 is not equal to 2, And so therefore, since this does not work out to the coordinate, we can eliminate b as well. Looking at coordinate -2, -1, if I were to substitute that in response A, I will have this. There is no need to work this out if I know that the first bracket results in a positive answer and the second bracket results also in a positive answer. And a positive times a positive is a positive. But the coordinates -2 gives a y value of -1, which is negative. And because y is not negative when x is -2, we can say that this does not satisfy the equation as well. This leaves me with response D. D is correct. A lot of information are given in this particular problem. However, to evaluate this, you can start this from the end point and work backwards. If we were to start from the number of marbles Ramesh had in the end, we can proceed to find out the total number of marbles. James' marbles will be twice times Ramesh's marbles. That is to say, 2 multiplied by, open brackets, x minus 1. This gives me 2x minus 2. Now we can derive Tony's marbles because it was given that Tony had 8 marbles fewer than James. This means that 2x minus 2 minus 8 would be Tony's marbles. But when we simplify that, that gives us 2x minus 10. Now we have Ramesh's, James, and Tony's marbles. We can sum all three to have the total number of marbles. That is 2x minus 10 plus 2x minus 2 plus x minus 1. When we group the terms that are alike, we will have this. And when this is simplified, we have this. Our answer therefore is C. To resolve an algebraic problem like this, sometimes it's necessary to give x a value and y a value. Let us say x is equal to 11 units and y equal to 9 units. Then the area of the rectangle here is xy, which is equal to 99 square units. Now the condition here states that the length is multiplied by 9. So if I were to multiply the length by 9, I would have 99 because 11 times 9 is 99. If I were to divide the width by 3, then I will divide 9 by 3 and this will give me 3. So that the new area will be 99 times 3. If we were to revert this to algebraic expression, you would recognize that 99 represents the area, xy. So we replace 99 with xy and we'd have the area algebraically. This gives us our answer. Our answer is therefore A. Some questions need the use of some formulae that you may not remember. So sometimes you see a question that you may not know how to resolve. You can simply look at the first page where a list of formulae is provided for you. Under the area of a triangle, you will see Heron's formula looking like this. This is used when you are given all 3 sides of the triangle. This is also indicated in the list of formulae. So all we have to do is follow the formula. If S is equal to A plus B plus C on 2, here we just simply put in the value for A, B and C and divide it by 2 and we will have this. Now that we have the value of S, we can substitute in our formula to have this. This simplifies to this. Keep in mind that you are not afforded the use of calculators in the exam. So when you are at this stage, I would recommend that you write your answer as a product of prime factors, like this. Next, you group all the prime factors that are the same together, like this. Then pair the prime factors like this. Your answer is found by multiplying one of the set within these bracketed prime factors by each other. So the area here will be 36 times 3, which is 96. This is therefore your answer. Thanks for watching, and please don't forget to like, share and subscribe. Let us improve the mathematics within the region.